Now we are going to do the physical properties of alkenes. So our first concern is that what is their state of existence at room temperature. So what is there? C2 to C4 are gases actually, that means the chain containing carbon 2 to carbon 4 are gases, 5 to 18 onwards are liquid and rest are gases. As we all know that they do not possess a strong forces between them, there exists a van der Waals force. So that is why their existence is like that, as we studied for alkenes also. So likewise here, but if we compare the intermolecular forces, then intermolecular forces are definitely higher in alkenes as compared to alkanes, because they possess actually the pi electrons. And we know that the pi electrons can be easily polarized, or they can somehow induce dipoles also. So this is the reason that there is a strong attractive force. Second is the density. If we talk about density, they are lighter than alkanes, even lighter than water. But as the members increase, obviously the attraction increase and the density also increase with increase in the molecular weight. Third we have is solubility. As they are non-polar, so we know that like dissolves like, so being non-polar they are soluble in the non-polar solvents, that is in the organic solvents like benzene and all. Fourth, the main question, the main important topic is the boiling and the melting point. So if we talk about the boiling and the melting point, you know that when we talk about the boiling point actually depend upon the intermolecular attractions actually, right? And the melting point depend upon that how closely they can be packed into a crystal lattice. So first we are taking into account a boiling point. So when we take into account a boiling point, obviously it is more than alkanes, the reason being there are pi electrons, as I told you, which can be easily polarized, and or you can say there is a strong attraction as compared to alkenes. So obviously the strong attraction corresponds to the higher boiling points, and that means more heat has to be supplied in order to boil it. So, but if we talk about its geometrical isomers of alkenes, as we know we have trans and cis, in which the two groups are present opposite to each other, and cis they are present on the same side. So if we talk about the dipole moment, you know that trans has zero dipole moment, because dipole due to this is being cancelled by it. But when we talk about cis, these two unite to form a resultant dipole, so that means it is not equal to 0. So that means in which out of cis and trans do you think have more stronger force of attraction? Obviously it is there in the cis, because here the dipoles are being cancelled, right? So here we have is a strong attraction. So strong attraction means that they will possess the high boiling point. So if you get a question that out of cis and a trans isomer which is going to have a higher boiling point, you are going to answer that the cis is going to possess the high boiling point, because in this case the dipole moment is not a 0. But now we will talk about melting point. Obviously, as I told you that melting point actually is based on that how closely packed substance can be in the lattice, or you can say the particles can how closely packed into a crystal lattice. That is what is a melting point. So if we talk about melting point, it is obviously higher than alkanes, but if we talk about again cis and trans, so as you can see that the trans is somehow symmetrical. Trans has a symmetrical structure and it has an unsymmetrical structure. So that means they can fit well into a crystal lattice. They can actually fit well into a crystal lattice. So that is why we say that trans has melting point high than the cis, but cis has boiling point high than the trans. So this is what is the physical properties.